You've always been, sort of at the leading edge, if not bleeding edge, of thinking about water issues and, take this as a compliment, but being provocative and getting people to think.
I'm not a big fan of this idea that the hydrological cycle has been disrupted. I mean, we're humans. We're part of the Earth system. We didn't come in here from outer space, I think the better way to think about it is that the water cycle is changing. Temperature increases are making it much more variable and much stronger. So a lot more exchange amongst the land and the ocean and the atmosphere. So that's the more flooding, the more drought. And of course, a lot more management and a lot of groundwater depletion, a lot of reservoir building. So, there's all that.
Tell me more about the NASA GRACE satellite. My take is that was a game changer. That was a big deal.
It's revolutionary in many ways. GRACE stands for Gravity Recovery Climate Experiment. Basically, it's like a giant scale in the sky. It's measuring the mass changes of water. And because we have now 22 years of data, we can start to look at the trends. So we can see not only the monthly ups and downs, but the trends of the regions around the world that are gaining and losing water. We have reached an all-hands-on-deck moment, and I think that the all-hands-on-deck scales from local to regional to national to global. And I think if we don't start making progress at those different scales, we are going to be completely screwed.
Welcome to the second season of Distilled. I'm Will Sarni. We have a very diverse group of water leaders, some of which you may not know, who are having a real impact in solving wicked water problems. Distilled is brought to you by KTM. You can find all of the episodes on Spotify and YouTube. Stay with us.
I was really looking forward to this conversation with Jay Famiglietti, who is the Global Futures Professor at Arizona State University. And I've known Jay for a long time and absolutely in awe of the work he did with the NASA GRACE satellite to really understand global groundwater issues. That really was a game changer and a trigger for the Sustainable Groundwater Management Act in California. And Jay does not fail to deliver in terms of being very much in touch with what's going on and what has to change in the world of water, and really, really great insights and really fabulous research at ASU right now. Jay, good to see you. Thanks for getting up early. You look marginally awake, which, my goal will be to wake you up, get you lit up on a topic, but thanks for doing this. Always good to see you and really value your take on the world of water. So Jay, on Distilled, what we do is we typically start with your origin story, where you started, what got you hooked on water, and what you've done of late, and where you see the world going in the world of water. You've always been, sort of at the leading edge, if not bleeding edge, of thinking about water issues and, take this as a compliment, but being provocative and getting people to think. So you grew up in Rhode Island, as I recall.
That's right.
What got you hooked on water? You started in engineering, as I recall, right?
I started in geology. So, yeah, I think I'm a product of the times in the sense that I was raised in the 1960s, and I was born in 1960. So by the time I could, think about things critically, I was more like over 10 years old, and to early 70s, and that's really when the environmental movement started kicking off. And I was experiencing it firsthand because, we go near the rivers are all polluted. This is New England, birthplace of the Industrial Revolution. So all the rivers were polluted, all the soil was contaminated. We're just starting to understand groundwater contamination in places where I'd like to spend time, like the beach and Narragansett Bay. were also heavily contaminated. The fish and the shellfish and the tuna and everything were really contaminated. And so this was also at a time when I was going to college and thinking about what I wanted to do. So, I have this strong sort of environmental conservation interest. But when I went to college, I went to Tufts University. I wanted to be a veterinarian. And I was woefully unprepared for the rigors of pre-med, pre-vet. So I was doing poorly. And then I found a geology class in my third semester. And that changed everything. And so then from there, it was, kind of a progression, graduate school, did a little bit of geophysics, but then got into hydrology and then did that for my PhD. And, time goes by fast, but that's the origins were, the 60s and the 70s and the first Earth Day and all that.
That's really interesting. Very similar to my background. I grew up in New York and became fascinated by geology and oceanography, actually, and then took a little bit of a detour and went into freshwater. And, the whole environmental movement was a big factor in me moving in that direction. So I can absolutely relate to it. Tell me a little bit about your early work, your research and your thinking and how that's changed over time. And of course, want to talk about your work, with the NASA GRACE satellite, which was,
Sure.
a milestone game changer.
Well, thank you. So I started off in my dissertation. I was very much interested in modeling computer simulation. And the problem at the time was trying to do things at a large enough scale or represent things that are happening over large areas so that we could improve the climate simulation models, the hydrology that was in the climate simulation models. Because if you think about IPCC models and climate change prediction, if we want to understand how climate change is going to impact water, the water needs to be well represented in those models. And it wasn't at the time, and it actually still isn't. So that's how I took off and, building these models and trying to work with the climate community. And things are great. My first faculty position was at the University of Texas in the geology department. And I didn't have a lot of that. Back then, it was very much a pure geology department. There was very little computational skill in the incoming students. And so I kind of shifted over looking at doing some field work. And so I did a lot of field work studying soil moisture variability, the moisture in the upper few centimeters of the soil. And the reason for doing that is because the community was trying to launch, speaking of satellites, a NASA soil moisture satellite. And so we really need to study the, patterns of soil moisture on the ground and what we thought the satellites would see and test out sensors with airplanes and all that stuff. So I did that for a while. But it was at the University of Texas where I got exposed to, you mentioned the NASA GRACE satellites. And that's where I got exposed to it because the principal investigator was there and there was a community of researchers who were trying to get me engaged. And it was difficult, but I made that jump. That must have been in the late 1990s.
And Jake, let's just go back to your comment that the hydrologic models in climate modeling are still, I'll say, inadequate, or not where they should be. Can you talk a little bit more about that?
Sure. So first of all, these climate simulation models, when we think about what these are the things that all the governments use to predict and understand climate change and minimizing temperature increases and the impact of CO2 and other greenhouse gases. And so we want those models to be as realistic as they possibly can be. The hydrology at the land surface. So the models themselves consist of a computer model for the continents and a computer model for the oceans and a computer model for the atmosphere and computer models for the ice sheets, and they're all linked together and they're heavily interacting. So on the land part of these models, the emphasis has really been on, I think, the carbon cycle, the CO2 exchange, energy balance. And so there's water involved, but it's really been more the vertical exchange of water and carbon and, and nutrients. So through evapotranspiration and heat and, carbon cycling. And that's been the emphasis. So for a long time, I've been pushing on the community to have a fuller representation of the hydrology that we experience as humans. So that means, rivers, that means watersheds, that means lakes, that means reservoirs, that means water management, like pumping, like groundwater pumping, that means irrigation. And so, it's coming along, but like many things in science, in the United States anyway, the investment isn't there. So the need to accelerate far outpaces the availability of funding. So that's why, we have the ideas and we know how to do it, but we never get enough funding to actually make a, great global hydrological model that can sit inside what we call a fully coupled Earth system model, or a very detailed climate model.
And I should know the name of the report, but the recent report that came out, a Global Commission on Water, that talked about how the hydrologic cycle has been disrupted by climate change. I believe it's a Rockstrom-led initiative. What's your take on that? I mean, does that get us any closer, or is that just, this is the J I want to get out of this conversation.
We call this, I guess, distilled or unfiltered.
We want this to be raw. Put it that way.
So I'm not crazy about, the Rockstrom, with Stockholm Environment Institute. Now I think he's in Potsdam, but the whole planetary boundaries concept, there are a lot of constructs out there. Are we going to be talking about the Sustainable Development Goals? Are we going to be talking about planetary boundaries? Do we have some other framework that we want to use? I'm not a big fan of this idea that the hydrological cycle has been disrupted. I mean, we're humans. We're part of the same, we tend to think of ourselves being separate from the system. We're not. We're part of the Earth system. We didn't come in here from outer space, we evolved. And I think the better way to think about it is that the water cycle is changing. And it's changing, for many reasons. Temperature increases are making it much more variable and much stronger. So a lot more exchange amongst the land and the ocean and the atmosphere. So that's the more flooding, the more drought. And of course, a lot more management and a lot of groundwater depletion, a lot of reservoir building. We're seeing more and more large-scale diversions. So, there's all that. And my thinking in working with the models, and it's still the same thinking that I apply when it comes to my satellite research, is that we need to do, people like me, if you were a university scientist or, in the past, a government scientist, need to provide the best available scientific information for our decision makers. And we need to communicate about it so they actually know about it. So, that's my goal. And that's a long way of saying I'm not crazy about some of the planetary boundary stuff.
So I am not a fan of the planetary boundary, the construct for water.
Yes.
Exactly. We live on a blue planet because there's an abundance of water. So the notion that we have exceeded the planetary boundary for water, I can't get my head around that. I can't reconcile it. But it's crazy. It dominates the conversation all the time. It's like, oh my God, we've, exceeded the planetary boundary for water.
Yeah.
What does that mean in a local watershed? It means zero. So, yeah, some of this stuff is really just not helpful.
No, I agree, Will, and you're right. It tends to dominate conversations, and then especially in places where you and I intersect, places like World Water Week in Stockholm, when there's hundreds of nonprofits and NGOs there, and they see this framework and they think it's great, and they try to use it. And I can tell you that we've worked on the planetary boundary. We tried to do a planetary boundary for groundwater with the Rostrom group, and it didn't work. It didn't work, and so we just said it's not going to work, and they went ahead and published their own paper without us.
Well, I'll buy you a lot of cocktails, and we'll talk about this more.
We're going to need more than one, I think.
Oh, there are definitely more than one, and I'm fully prepared for that. Tell me more about the NASA GRACE satellite, and let me give you my take on it, and feel free to tell me I'm totally wrong. But when the GRACE results showed up, it completely went around the need to ask farmers in California to measure water levels. Now, as I understand it, for the longest time, the ag sector in California was not required to measure water levels. Suddenly, we've got satellite data that gives us a sense of what groundwater levels are doing. And I believe that triggered or contributed to changes in the regulatory environment that now require the ag sector to measure water levels. Is my take correct on that?
Yes.
Well, then I'm going to call it a week, Jay. That's great news. But tell me, so for people listening to Distilled, talk a little bit about what that was, because my take is that was a game changer. That was a big,
thank you
deal.
very much. I appreciate that. We did a lot of work on it. We started, I mentioned we started in the mid to late 90s working on it when I was at the University of Texas. So I think it has been a game changer. And it's great to hear people who are like, not in my sphere say that, because, we all tend to work on our own bubbles. So yeah, it's revolutionary in many ways. And the biggest way is that it's measuring something completely different than traditional satellites, which are more like cameras or telescopes or thermometers. And this pair of satellites, GRACE stands for Gravity Recovery and Climate Experiment, measures, basically it's like a giant scale in the sky. It's measuring the mass changes of water in and out of a region, large regions, like, a watershed that's 100,000 square kilometers, but that's globally, you get pretty good resolution. And so what it has allowed us to see is the regions around the world that are gaining or losing water mass on a monthly basis. And since we've been doing it, so we can see the ups and downs, so we can see the seesaw, we can take the upper Colorado, river basin, or, some sub-basin that's smaller than that, and look at the monthly ups and downs, right? So wet season, dry season, wet season, dry season. And if there's a trend, it becomes very clear because of climate change. In the case of the Colorado, there's acidification, there's increasing temperature, increasing evaporation, less snow, a lot of groundwater depletion. And so there's a trend. So we can see the monthly ups and downs, which is great because that was brand new information. We did not know what the storage changes were. And because we have now 22 years of data, we can start to look at the trends. So we can see not only the monthly ups and downs, but the trends of the regions around the world that are gaining and losing water. And you've seen these maps of mine, Will, and you know what they look like. And, we see a very compelling picture of the mid-latitudes getting drier and drier and drier. Climate change models tell us that the tropics and the high latitudes should be getting wetter because of climate change. More rain, probably more flooding, more variable. And in between the mid-latitudes, which is where we grow all of our food, and where we use all the groundwater, they're expected to get drier. And so we see that very clearly, but we also see the hotspots for things that are really intense, like groundwater depletion in the Central Valley, like groundwater depletion in the North China Plain, or in the Ogallala Aquifer. And it's that work that you're talking about, Will, that really got the attention in California, the Central Valley work, being able to say, here's how much groundwater depletion there is, on a monthly basis over the last decade, over the last 2 decades. And it's not pretty. And it's faster than, it has been in the past.
Fascinating. So as I understand it, GRACE has been replaced by other satellites.
There's
doing something similar?
So the GRACE mission, interesting story. Talk about return on investment. This was, the GRACE mission was launched in 2002 under a small satellite program called the Earth System Science Pathfinder program. And I forgot what the budget cap was. It might have been $500 million, and it was shared with Germany. It was supposed to last for 5 years, but it lasted for 15 years. So it went from 2002 to 2017, and then we launched basically a carbon copy mission, a copy mission, which we called the GRACE follow-on. And that launched in 2018, and it's still up there. So we've got, from 2002 up to the present, we've got 22 years of continuous water storage change data.
That's amazing. Yeah, really, really amazing in terms of how it changed thinking about groundwater.
I hope that it has. And sometimes it does. I think we had a moment there in California where I think we had a colossal drought. So the groundwater, Sustainable Groundwater Management Act was passed in California in 2014. And the State Water Resources Control Board, so people like Felicia Marcus, who was the chair of the board at the time, were very clear about pointing to the contributions from my team. So these GRACE data, some of the animations that we did, which we could share with you, some of the imagery that we were able to do. In groundwater, we talk about making the invisible visible. And so we're able to do that a little bit in California. But the reason I think that we were able to have that kind of impact was that, it was a combination of not just the science and not just me, but having a governor, Jerry Brown, who was motivated, having a state water resources control board led by Felicia that was really motivated, having the press be totally on board and writing about it all the time. All that, I think, really contributed to the passage of the Sustainable Groundwater Management.
As an outsider, being in Colorado, it struck me that was a key part of it going forward. And then, having Felicia as a force of nature. What's your take on what's going on right now in the world of water? Give me the good, the bad, and the ugly. Like your take, sitting in the American West, but also being really engaged internationally.
Okay, so can we call it just the ugly?
Yeah.
No. So it's funny. I did a talk. I should send you the slides. I did a talk at the University of Montana. I call it the good, the bad, and the ugly. But I can't remember what I said. But let me see if I can sort of recover some of that from my mental storage. So the good is we've made a lot of progress, and we're having a lot of success with technology from small scale to global scale. And so there's a new focus on it. There's water and groundwater legislation that's being passed, and so I think we really elevated the water story. The bad is that it is remains very complex and very intertwined with politics, with economics, with international relations. And the ugly is climate change and groundwater depletion. And, this, my pessimistic side, I'll expose my pessimistic side if I haven't already. right now, I don't see it getting much better. I think we're in really, really rough shape.
So I share your view on that, but what has to change? I mean, is it governance? Is it investment? Is it technology? Is it, you said making groundwater visible, which certainly you contributed to, or, all of the above.
Yeah,
I mean, it sounds like everything's broken.
It is. And there's no question. You know that, and I know that. And we know the answer is not one thing. All those things have to change. And so let's take the overall awareness. It's really, really hard. I went to COP28 last year, and this was like the first time they were going to have a water day. Do you know from being there and from just witnessing what just happened, the focus is that it's very much on oil, and the language around oil. And so, water stuff, we can't, it's very, very difficult to raise it to that level. So, we need to do other things. And so investment is really, really important. And so, you work with investors, getting investors. I worked with Ceres, the nonprofit that works with sustainability investors, forcing or driving corporate water stewardship, enabling that is really, really important, because at the end of the day, it's the private sector that uses all the water, and a lot of it's agriculture. So, that has to happen. And embedded in there is the technology. And then, of course, the governance. I mean, we look at these transboundary aquifers. I have students now from Egypt and from Uganda and from Bangladesh, and they're telling me firsthand, this is not happening. We're not having these discussions. So much that has to happen. That's why I'm a pessimist.
Yeah. My take is, there's good stories coming out of, the good stories associated with technology I would even say investing, a greater interest in, venture investments, more holistic thinking around it. But public policy just doesn't seem to get it. It's just so hard to change public policy. I mean, even in the Colorado, not even in the Colorado, but, maybe that's a great example of, why things move slowly.
I think we're headed down a really dangerous path in the Colorado, and I think that all the states are playing chicken with each other. So, yeah, I mean, let me back up a little bit and say, given all this that we just talked about, the complexities of water and how to make progress, that's why I tend to focus on my research, controlling what I can control, do the research that I can do, and communicate about it. And when there are little victories, we should celebrate. And an example is our governor, Katie Hobbs in Arizona. From the day she started, which was like the day I started at ASU on January 1st, 2023, she said, I want to change groundwater legislation. I want to make sure, only 16% of Arizona by area is covered by groundwater management. So we call the rest rural groundwater. And so she came in and said, I want your rural groundwater management. So that's awesome. And so we're able to work with the governor's office. We're able to work with the attorney general's office and take the small victories when we can. So, for example, Governor Hobbs is now adding or trying to add, it looks like it's going to happen. We have these 6, they're called active management areas. They're just regions that collectively add up to the 16%. So there's the Phoenix one, there's Tucson. And so anyway, there's another one that's going to be added. And it maybe will take the state up to whatever, 19%, but that's a victory. because a lot of water gets used in that particular region. This is down in the southeastern part of Arizona, where there's agriculture and there's deep groundwater pumping and there's wineries and there's a lot of water use. So, I'm kind of, I love talking about the big picture, but I'm also realistic about, given my age. I disclosed my birth year earlier. What can we do in the time that we have? And so I'm focusing on the research and the communication and focusing on the satellite groundwater stuff.
It's very stoic of you, by the way. Control what you can, and I like that. I think it's really the right way to approach it. I was talking to Stu Orr a while ago from WWF, and Stu said, "I'm going to focus on what's working, and just scale it. Like just chipping away at it, as opposed to really trying to boil the ocean, as they say, because." We know how problematic that is.
Also, the ocean's already boiling, so we're in trouble.
Yeah, right. A good point. That was clearly not intentional.
That only took us like 200 years to get that done. So, no, I agree. I mean, there's so much to do, and it's nice to think that we can all work together. We can intersect on some things. You and I intersect on things. You and Stu intersect. We have some intersection. And we do go for the greater good. And that's fantastic. We need to do that. But I think we need to start taking stock, or else we're just going to, stress ourselves out and die. If feel like we've been like completely useless. We actually haven't been. We've accomplished a lot. It's just that, talking about scale, the scale of the problem is just so much bigger. You and I, and your listeners and our friends and our colleagues all understand the scale and the scope and the urgency, but the rest of the world does not. And I think
that's what we need to work on
behind temperature and carbon.
Well, I'll second that. So Jay, in about 60 seconds, tell me what you think about the future of water.
I think the future of water is stressed and complicated. I think that we have reached an all hands on deck moment, and I think that the all hands on deck scales from local to regional to national to global. And I think if we don't start making progress at those different scales, we are going to be completely screwed.
Well, that's a sort of optimistic note on a Monday morning. I appreciate that.
It's the best I can do, Will.
Jay, I really wanted Jay unvarnished. Raw.
Yes.
Thanks. So, where can everybody reach you? Just track your work, understand what you're doing, your point of view.
Yeah.
What's the best way to...
No, thanks for asking that. So a few places. One is just, I'm at ASU. If you Google me, my email addresses are just my name, Gmail at ASU, but easy to find at ASU. I'm off Twitter now, have been for a few years, but I'm LinkedIn, and I'm just J Famiglietti on Twitter. As I've done a ton of media stuff. And so, look for me on YouTube. You'll find more than you want. And I do want to say that we are, I finally decided to come up with a name for our research group. And so we're going to be launching like a webpage and a LinkedIn site. And we're the WISE group, Water Innovations for a Sustainable Earth. And so hopefully that will get out there.
I love that name. It goes with the gray hair.
Which is why it works. Why it works for me. One of my students came up with it, and that's exactly what I thought. It's like a lot of ways we could go with the name, but okay, this one works.
Thanks so much, Jay.
My pleasure.
Keep being unreasonable.
Yes, we must. Let's say it. I think it's our lot in life, and I think we need to lean into it.
It is our lot in life. All right. Good to see you. Thank you.
Thanks.